Today's lesson is going to start our chapter of systems of equations. So before we just graphed one line at a time, and now we're going to graph two lines. So the word system simply means more than one equation that you're going to handle in a problem. So all your solutions to these systems are going to be ordered pairs, and they have to satisfy both equations. So what I mean right now is if you were to guess a solution for this, let's say you guessed 0, 2. We'll keep it easy. What we have to do is we have to put those into each formula. So I'd have to put 2 in for y, and I have to put 0 in for x. And I also have to do it to this equation, because together this is a system. So I have 3 halves times 0 plus 2 in for y equals 4. So right off the bat, 1 half times 0 will not equal 2. So this doesn't work. So this is not a solution. However, if I try the point 4, 2, and I put 2 in for y and 4 in for x, 1 half times 4 is equal to 2. So it works for that equation. However, it has to work for both, so we have to check that ordered pair with this equation. So if I do 3 halves times 4, and then I add 2, let's see if we get 4. 3 halves times 4 would give you 6. 6 plus 2 is not 4. So even though this worked for the first equation, it is not a solution for the second one, so it's not a solution to the system. And we could go all day and try to guess all these ordered pairs. That's going to take forever. So it's much, much quicker if we graph our two equations. So we're going to graph y equals x very quickly. Start at 0, 1, 2, 1, 2. And I also want to go down and left as well. So you want to extend your line across the whole graph. So in these particular problems, neatness counts, so you want as many dots as you can have. This one really quick, I need to rearrange it, so it needs to be negative 3 halves x plus 4. Now I can graph it. So we're going to go to 4, we're going to go down 3, right 2. How about that? We landed on our line. We'll do it again, down 3, right 2. And we try to make a line as neatly as we can. So the important part of having all these dots is that you can see the clear point where those two lines intersect. That point is the solution to the problem. So if I were to sit here and guess all day, hopefully I'd eventually guess 2, 1, because that does work. And if you really want to check it super quick, we're going to plug those in to our starting formulas. So we're going to put 1 in for y, and we're going to put 2 in for x. Again, we're going to put 1 in for y, and 2 in for x. And we just want to make sure that that works. Half of 2 is 1. Negative 3 halves times 2 is negative 3 plus 1, or excuse me, 4 is 1. All right, so I know that 2, 1 is correct. I did my work right. So it's a little bit quicker to graph and get the intersection than it is to sit here and guess all day. So when you do your homework tonight, there's 3 possible answers that you could get. And the first one is what we just did, where you'll graph each of your lines, and they will eventually crisscross. That's called a one solution or an independent system. The other scenario is you'll have parallel lines. So when you graph your lines, they'll look like this. They will never intersect, so we say there's no solution. You can also draw a 0 with a slash through it. The third case, you would have graph a line, and as you graph your second line, you're going to realize these are the same line. So if you catch that early on, great. If not, hopefully you'll catch it when you graph it. If that happens, there are infinite solutions because everything that's on the red line will also be on the blue. So they'll always intersect. So what we're going to do now is I want you to pause the video and I want you to graph all the lines in 1 through 3. Just graph them and then we'll talk about the solutions. So go ahead and check your lines. Make sure that you did your math right up here. And then notice all the dots that I have on my lines. You want to extend these as far as you can so that you have a more accurate answer. Once you do that, all you have to do is record the intersection of the lines. So at -1, -2, these lines intersect. So that ordered pair is the one and only solution. At this one, they intersect at 2, -3. That is the only solution. And at this one, they intersect at 2, 1. So that is the only solution to that system. And if I were to plug these values into both equations, you'll see that it works for both of them. It's just graphing is a lot quicker. So in number 4, if we really quickly solve for y, we get -2x plus 6. And just to save on time, we will get 2x plus 2. So if I graph those quick, I have 2, up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1. You can see how I kind of keep counting my slope and putting a new dot every time. So I get a pretty good line from that. And then we're going to start at 6. We're going to go down 2, right 1, down 2, right 1, down 2, right 1. And if we were to go on forever, I think we can see our two lines will crisscross. So it's right there. So even though my lines are kind of sloppy, my point is at 1, 4. Now, if I were to do number 5, if I were to solve for y very quickly, eventually I would get -3 halves x plus 3. And then for this one, I'd get y equals -3 halves x minus 2. So I actually don't need to graph these because I can tell right now they have the same slope. So they're going to be parallel. And parallel means there's no solution. And if you want to check it, you're welcome to, but we start at 3 and we go down 3, right 2, down 3, right 2. We start at -2, and again we go down 3, right 2, down 3, right 2. You will graph a pair of parallel lines. So they will never intersect. In the last one, we're going to go ahead and solve for y first. So if I divide everything by 2, I'm going to get y equals -2x plus 2. Now, before you go off and just graph these, you really want to observe them. So your answer up here is actually the same as the other equation. So when that happens, it's not necessary to graph the lines because obviously they're going to be the same line. So when that happens, all we do is we write infinite solutions. So usually when you're doing parallel lines or same lines, you really don't need to do the graphing part because you should be able to pick up on it and either know it's no solution or infinite. All right, the last one I borrowed from the Keystone practice test. So we have two situations. We have Nolan's money and Claire's money. Nolan has 15 and makes 6 per hour. So we're going to write an equation for Nolan. So it looks like 6 is my slope and 15 is the y-intercept. And then for Claire, it looks like she's making 8 per hour, so that's the slope. And it says she has $9 to start. So what they want you to do is they want you to graph these equations and try to use the graph to find a solution. So you kind of have to think here. We need to start at 15 or 9. And we need to basically count up 6 and over 1, which means we might need to scale this small. So I would probably scale it maybe by 2s or 3s. So we'll try 3s and see what kind of answers we get. 3, 6, 9, and so on. All right, so my first line is going to start at 9, and we're going to go up 8. So we are going to have to estimate. So remember, each block up counts as 3. So we're going to go up 3, 6, 8 would be probably about here, and then to the right 1. Okay, so it looks like I'm going up about 2 and just over a half blocks every time. So I'm going to do it again. 1, 2, and about a half a block. So maybe somewhere around here. And we'll just kind of draw that line, just because they did say they want us to graph it. Now we're going to do Nolan's. So we're going to start at 15, and we're going to go up 6, so that's 2 blocks and over 1, 2 blocks over 1, 2 blocks over 1, etc. And then we're just going to draw our line. So the reason that I'm doing it this way to show you guys is it's not really that very clear where they crisscross. It looks like if I were to extend Claire's line, it looks like they might be about here. So I would kind of estimate and say maybe 3 hours is when they have the same amount of money. So we're just going to try that and see what each of them has after 3 hours. So for Nolan, he's going to have 6 times 3 plus $15. And for Claire, she's going to have 8 times 3 hours plus $9. And let's just get those answers and see what we get. We get 18 and 15, which is going to be 33. And then we're going to get 24 plus 9, which is very conveniently also 33. So 3, 33 is the exact point where these intersect. So usually we use the graph to the best of our ability, and we kind of estimate. It looks like they cross between maybe 3 and 4 hours, and we just kind of go from there.